Hello, everyone. As an astrophysicist who has spent a lifetime analyzing data at NASA, I'm used to the weird. We've seen millisecond pulsars, black holes devouring matter, and planets where it rains glass. The universe always plays by the rules of physics. Until now. We had Oumuamua in 2017. It was weird. We had Borisov in 2019. It looked just like a normal comet, reassuringly familiar. We thought we understood the pattern. Every so often, interstellar space throws us a scrap from the neighbor's yard. But the third object, the one observatories have just named Atlas, it isn't a scrap. It's a mountain. Atlas has an estimated diameter of 5 kilometers. To put that in perspective, it is thousands, perhaps millions of times more massive than our previous two visitors. From an astrophysical standpoint, this should be nearly impossible. Our models show that ejecting a small object like Oumuamua from its home system is hard enough. But to throw a 5 kilometers object, a planetesimal, into the interstellar void requires an extreme gravitational force, a profoundly chaotic event. But the size isn't the only problem, it's the behavior. It's breaking every fundamental rule of comets. As it approaches the sun, it isn't outgassing like Borisov, it has no tail. But it isn't moving like an inert, rocky asteroid either. Something is wrong. As my team at NASA compiled the orbital and spectral data, we found not one, but 8 distinct anomalies. Deviations from known physics that we simply cannot explain. Based on these 8 anomalies, I put forward a number that has made many of my colleagues uncomfortable. I'm giving it a 40% probability that we are looking at something technological in origin. There is something moving through our solar system that shouldn't exist. This isn't just another space rock. This is a discovery that could force humanity to rethink everything we believe about our place in the cosmos. What we are about to learn about Atlas in the episodes to come could change everything. If you want to join this journey into the raw data and unlock the secrets of the universe, hit like and subscribe. We're going to crack this mystery together. I can tell you this. The universe has an order, even in its chaos. There are always more pebbles than stones, more stones than boulders, and more boulders than mountains. This is called the power law distribution. It's a fundamental rule. Atlas breaks that rule. In the last segment, I mentioned the 8 anomalies and my controversial 40% number. Let's dive into the first 2 because they are the foundation for everything else. Anomaly Hashon, the statistical absurdity. Imagine you watched the highway for years and only saw 3 vehicles. The first is a motorcycle, Oumuamua. The second is a sedan, Borisov. And the third is an aircraft carrier, Atlas. This is exactly what we just observed. According to every model from NASA and the ESA, we should have detected hundreds, maybe thousands of Oumuamua-sized objects before we stumbled on one as large as Atlas. The fact that we observed small, and then gargantuan completely defies all our expectations of interstellar populations. Statistically, this isn't just strange. It's practically impossible. But size isn't just a number. It's potential. A 5 kilometers object isn't just a boulder. It's a small world. If it's artificial, it has enough room for things smaller probes could never hold. Sophisticated propulsion systems. Multiple layers of radiation shielding. Laboratories. Data centers. And yes, possibly a crew or a self-sustaining ecosystem. Its sheer mass means it could protect complex technology within from the ravages of millions of years of interstellar travel. Anomaly H2, the impossible orbit, this one is even more disturbing. Picture our solar system. The planets Earth, Mars, Jupiter all orbit the Sun on the same relatively flat plane. We call this the ecliptic plane. It is essentially the solar system's highway. Interstellar space is 3D. A random visitor, like Oumuamua or Borisov, should have arrived from any random angle, plunging down from above or rising up from below that plane. That's what randomness dictates. Atlas didn't. Its trajectory is aligned almost perfectly with the ecliptic plane. To put it simply, it didn't just stumble into our solar system randomly, it flew in almost parallel to the planetary highway. This is the most energy-efficient trajectory if you want to visit the inner planets. It's the exact path our own engineers at the Jet Propulsion Laboratory, JPL, would plot for a mission. A natural object shouldn't behave this way. The combination of its sheer size and such a deliberate trajectory, it's forcing me to think, and we haven't even gotten to the strangest part. Its composition and the way it's changing its velocity. The orbital simulations just finished. The results are even more alarming than we thought. What we are tracking no longer looks like a random cosmic event. It's starting to look like precision navigation. Its inclination is just 5 degrees off the ecliptic plane. The probability of a random interstellar visitor naturally aligning itself this precisely with our highway, about 1 inch 500. That is a staggering coincidence. But it is nothing compared to the next anomaly. Anomalies #3 and #4, the Grand Tour itinerary. Atlas isn't just flying by. It is conducting a tightly scheduled tour, October 2nd, 2025. It passes Mars at a range of only 30 million kilometers, October 29th, 2025. It reaches perihelion, its closest approach to the Sun, December 2025. It will make its closest approach to Earth, March 2026. It will fly by Jupiter, Mars, Earth, Jupiter. This is not a random trajectory. This is the basic playbook for an interplanetary mission. Our engineers at JPL use this exact flyby sequence to gather data and perform gravity assists. I ran the probabilities myself. The odds of a natural object entering the solar system and happening to visit the 3 most important planets for interplanetary study in this sequence are approximately 1 inch 20,000. No, this does not prove intent. But in science, when we see a 1 in 20,000 event, we don't call it bad luck. We call it extremely powerful evidence that demands an explanation. It's the temporal precision that truly gets me. Each planetary approach offers a perfect window for observation and data collection. If I were designing a reconnaissance probe, I couldn't have planned it better. Anomaly #5. Chemistry from another world. Orbits can be argued. Chemistry cannot. Chemistry is the fingerprint. We pointed our best instruments, the James Webb Space Telescope and Hubble, at Atlas. We expected to find the usual cometary ingredients, signatures of water, H2O, carbon compounds, maybe some silicates. Instead, what we found challenges decades of cometary science. The spectrum showed Atlas was venting nickel. The chemical fingerprint we found, it isn't just weird, it's unnatural. We've talked about the orbit. Now let's talk about the material. Anomalies #5 and #6. The impossible chemistry, the James Webb spectrometer, sent back the data. Atlas is venting 4 grams of nickel per second. By itself, that is remarkable. But the thing that truly stunned my entire team at NASA was what wasn't there, iron. In the cosmos, iron and nickel are brothers. They are born together in supernovae. Every comet, every asteroid we have ever analyzed has both. Atlas shatters this fundamental rule. It is venting almost pure nickel with no corresponding iron signature. Finding pure nickel without iron in nature is like finding bones without calcium. It implies refinement. And then we found the impossible. Among the emissions, the spectrometer locked onto a molecule that has no business being there. Nickel tetracarbonyl. The spectrographers on my team had to run the analysis 3 times. This is a compound that, on Earth, we almost exclusively associate with industrial processes and aerospace applications. It is incredibly unstable and rarely forms in a natural environment. It has never been detected in deep space. Furthermore, its ratios are completely wrong. The carbon dioxide to water ratio is 8:1. A normal comet is the exact opposite. They are fundamentally dirty snowballs. Atlas is not a comet. It was engineered to operate in completely different conditions. Anomaly #7, the physics defying jet. But it's the 7th anomaly that defies the most fundamental physics. This is an ironclad rule in astrophysics. The solar wind, the constant stream of charged particles blowing from the sun, always pushes a comet's tail away from the sunday. It's why a comet's tail always points away from our star. We imaged Atlas with Hubble. It has a jet, but it is pointing directly at the sunday. A jet pointing towards the sun isn't a tail. It's a retrothrust. It isn't being blown by the solar wind. It is fighting the solar wind. It is slowing down. The observatories have confirmed. Data from the Nordic Optical Telescope and Gemini South just went public. The images, they confirm the impossible. Anomaly #7 confirmed the sun-facing jet. This is no longer theory. We have clear images. Atlas is ejecting a stream of material against the solar wind. It is flying straight at our central star, defying every law of cometary physics we know. An astronomer on my team put it this way: we are essentially watching a river flow back up a mountain. Technically, we try to find natural explanations. A strange combination of magnetic fields, bizarre asymmetric sublimation. But every natural model we ran either failed or required absurd conditions. Our aerospace engineers at JPL, however, had a different perspective. They said this configuration, a controlled jet of material aimed at the heat source, looks suspiciously like a braking propulsion system, an active heat shield using ejected mass to manage temperature and attitude control as it approaches a star. Anomaly #8. The impossible stability. This is the final anomaly, and it might be the clincher. When a comet outgasses, it's like thousands of tiny random thrusters firing off its surface. These forces push the comet off its path. We call this non-gravitational force. Borisov, our previous interstellar visitor, was pushed 100 kilometers per day by these effects. Atlas, at its peak, is ejecting a massive amount of material, 150 kilograms per second. With that much force, it should be getting violently blown off course. But our orbital data shows the exact opposite. Atlas is deviating by less than 15 meters per day. It is almost immune to its own eruptions. As one orbital dynamicist put it, it's like it's performing its own thrust compensation. There are only 2 explanations. Extreme mass. It is so heavy that 150 kg divided by sec is just a mosquito bite. This is possible, but it implies a material density we have never seen. An active stabilization system, something perhaps small thrusters, gyroscopes, or the main propulsion system itself, is actively correcting to keep it perfectly on course. Faced with this accumulation of 8 anomalies, a cascade of statistical and physical near impossibilities, we are forced to do what science always does. Consider the hypothesis that best fits all the data. 8 anomalies, 8 rules of physics, bent. We need a way to quantify this suspicion. I've created a scale, a method for classifying potentially artificial objects. We're calling it the loss scale. 0, a completely natural object, like Comet Borisov. 10, a clear technological threat to humanity. Based on the 8 separate anomalies, Atlas presence, I've placed it at a 4. In other words, a 40% probability that we are looking at technology, as I explained to the review committee. This is a cosmic blind date. On the other side, we might find a harmless science mission or something that will permanently alter our understanding of the universe. We simply don't know. My colleagues, they are more conservative. But even the biggest skeptics must admit, whether natural or artificial, Atlas is an outlier. It is forcing us to expand our understanding of what is possible. The critical window, right now, Atlas is approaching the most critical moment of its entire journey. October 29th, 2025. On that day, it will pass perihelion, its closest point to the Sunday. This is the moment everything happens. If Atlas is a probe, this is when it activates. Proximity to the Sun provides the most abundant energy. It's the perfect time to recharge, gather data on our star, or use the Sun's gravity to perform a complex braking maneuver or orbital change. This is when we'll get our answers. There's just one problem. During this exact critical moment, when it is at its most active, Atlas will be obscured. From Earth's perspective, it will be flying behind the Sunday. Our best telescopes, Hubble, Webb, and every ground-based observatory will be completely blinded by the Sun's glare. We are about to lose the feed. Right at the climax, the irony is thick, I admitted to my team. The most critical moment, its perihelion on October 29th, the very time it might activate, is the one time we cannot see it. We have a few slim hopes. The ESA's JUICE, Jupiter Icy Moons Explorer, and possibly NASA's Juno, currently at Jupiter, might be able to gather some data as it passes, but their capabilities are limited. They weren't designed for this. The urgency in the scientific community is palpable. Colleagues are pushing for emergency missions, small, agile probes that could launch now to intercept Atlas. It's an ambitious, perhaps impossible idea, but it shows just how seriously we are taking this object. What happens next? We are facing two possibilities. If Atlas is natural, it will represent an extraordinary discovery about the diversity of interstellar objects, forcing us to rewrite astrophysical models. If it is something more, it will fundamentally change our understanding of our place in the cosmos. The wait won't be long. In December 2025, Atlas will re-emerge from behind the Sunday, and this time it won't just be for NASA or the ESA. It will be close enough and bright enough for anyone with a 50 centimeters, 20-inch diameter telescope to observe it directly. It will be a historic moment. For the first time, the public may be able to directly observe an object that could represent our first proof of extraterrestrial technology. The truth is coming. Atlas isn't just another space object. It is a fundamental question about the nature of reality, streaking through our solar system at 55 kilometers per second. Its anomalies are real. Its chemistry is impossible. Its trajectory defies. We are on the threshold. The data is no longer just numbers. It is an indictment of our solitude. Atlas's trajectory defies all astronomical probability. But perhaps most important is what Atlas represents for our species. For the first time in human history, we have an object, something we can point to in the sky that could be the first concrete proof that we are not alone in the universe. Now, we wait. In the coming weeks, as it clears perihelion and emerges on the other side of the sun, every single observation is critical. Every spectral line, every image, every orbital measurement could be the final piece of the puzzle, the piece that changes everything. The telescopes are ready. Teams across the globe are working in 24-hour shifts. Special protocols have been enacted at NASA and partner agencies. These are the procedures previously only theoretical in case the object does something unexpected, a sudden orbital burn. a deliberate radio signal, any behavior that cannot be explained by natural processes. If Atlas is an extraterrestrial probe, this could be the moment of first contact. It won't look like Hollywood imagined. There will be no massive mothership blotting out the sky over New York. It will happen through scientific data, through the spectrum of light, the math of orbits, and the precise measurements that will reveal the truth of our place in the cosmos. And if it is natural, that would still be a revolution. It would prove that the universe is capable of creating objects so bizarre and complex that they completely defy our current understanding of space, physics, and chemistry. Some scientists are already bracing for a new reality where impossible is simply a synonym for undiscovered. The truth is coming, and we are watching. We have already entered a new era. Even before we have the final answer, Atlas has changed everything. In the briefing rooms at NASA and in universities across the globe, the revolution has already begun. Some scientists are already drafting papers that could redefine our entire understanding of interstellar objects. Others are developing new protocols for future discoveries. Because one thing is certain, Atlas will not be the last strange visitor. This discovery also raises urgent questions about our own preparedness. Do we have enough observational tools? Do we have the right protocols in place? Do we have the rapid response capability required? These are questions humanity has never had to ask in earnest. But now, with Atlas navigating our home turf, they have become immediate and real. The permanent legacy, no matter what we find natural or artificial, Atlas has already changed science fundamentally. It has forced us to question our most basic assumptions about what is possible in the cosmos. Before Atlas, the search for extraterrestrial intelligence, SETI, was largely theoretical. Now, we have a tangible, observable object that represents our first potential evidence of alien technology. This has changed the scientific conversation. Theories once considered too speculative, too fringe, are now being discussed seriously at prestigious conferences. Funding for SETI research has increased. New telescopes are being designed specifically to detect anomalous objects. Atlas has also proven one unsettling truth: our cosmic vulnerability. If it were a threat, we would have had only months. Months. We would have had months of warning to try and react. Part 10. The 5-kilometer truth. The discovery of Atlas has exposed our cosmic vulnerability. Immediately, it has sparked serious discussions at the highest levels about planetary defense. This is no longer about theoretical protocols for dealing with natural asteroids. We now confront the reality that we need response protocols for potentially hazardous objects, objects whose intent we cannot predict. But its deepest impact, its most lasting legacy, is philosophical. Atlas has reminded us that we are part of something so much bigger, that our little blue rock orbits an average star in a galaxy teeming with mysteries. And some of those mysteries are coming to visit. One thing is certain. Whatever we discover, Atlas has changed science forever. It has forced us to question our most basic assumptions about what is possible in the cosmos. All of us, from NASA scientists to amateur observers, will never look at the night sky the same way again. Because now, we know that out there between the stars, the impossible is moving, and some of it is heading our way. The future of humanity may depend on how well we understand these visits. And it all started with a single slow-moving point of light against the stars, carrying secrets that could change everything we thought we knew about our place in the cosmos. The truth is coming, and it is 5 kilometers wide,